All right, this is Mrs. Slauson. Here's review. A couple things you're going to probably want to have is your calculator or something that can help you with the list of factors. And then you will also want your flip book because I'll be letting you use this on the test. So one thing you want to make sure is that you have this. So one thing you could do is take a screenshot of this, and get it copied, borrow from a friend. But you would want this for the test. It will be helpful, and I will not be loaning mine out. All right, starting with the first question. For each expression, we're going to determine if it's better represented as factors or terms. Just so you know, we kind of mentioned that on the back. We're going to list them, and then we're going to state what form it's in. So I'm actually going to start with the form. So the first form that this is in factored form. So if you look on the back of your flip book, when we said something was in factored form, that it best showed things as factors. So this was a factor, this was a factor, this was a factor. So this is better listed as factors, so I'm just going to put a star by it, not as terms. And the factors are x. Another one I'm going to separate it very far is 2x plus 1, and the other one is x minus 4. So that's problem 1. All right, number 2, what form is this best one in? So with no parentheses, that's standard form. So I'm going to start with SF. And standard form, we said were represented as terms. So I'll put a star by that one, or you could just cross the other one off. And the terms are 3x to the 4th. Another one is technically negative 2x third. We have 4x, and we have 7. So we have 4 terms on that one. On the next problem, what form is this in? So anything with parentheses squared is in vertex form. So it just depends if there's something added on the end or if there's not something added on the end. If there's something added on the end like this one is, then we would view this as terms. So there is something subtracted at the end. So first let me put VF for vertex form. We will not view this as factors. And one term is the whole x plus 3 squared, and the other term is the negative 12. All right, the next set, we will either be adding, subtracting, multiplying, which again is just those neighbors meet the neighbors, and then classifying it after we've done that. So where you would want to look here, is classifying with the different names. And then if you don't remember how to add and subtract or the multiplying. So first thing I'm going to do is go left to right, and I'm going to add the opposite. And the first time I ever see a minus sign is here, so I'm going to add the opposite. And I'm just going to rewrite it and stack my like terms. I'm going to put a 1 in front of that x. And I'm just going to add these up, and I get 5x squared plus negative 1x plus 3. So when I'm done, just a reminder, we haven't done this for a while, that highest exponent, a 2 makes it a quadratic, and with 3 terms, I would call it a trinomial. So quadratic, trinomial. All right, the next one is a subtraction problem. So I'm going to go through and change my subtraction. So going left to right, x minus 3, I'm going to add the opposite. And this minus is for everything, so I'm going to add and take the opposite, and the opposite. And I'm going to rewrite it. So 2x squared, 1x, negative 3, which I'll pair with negative 5x squared, negative 3x, and negative 2. And when I add them up, I get negative 3x squared, negative 2x, and negative 5. And this is the same as the other one. This is a quadratic due to the 2, and trinomial because we have 3 terms. All right, going to C. So this is a neighbor meets neighbors. I am going to go ahead and left, right, and add the opposite here. And 5x is going to be visiting all 3 of these. So 5x with 3x squared, that gives me 15x cubed. 5x with negative 2x, that gives me negative 10x, and 5x with 4 give me 20. So naming this one, the highest power being a 3, I would call it cubic, and I still have 3 terms, so it's a trinomial. All right, D, neighbors meet neighbors, so I'm going to go through, add the opposite real quick on that minus 2, and I'm going to have 2x go and meet everyone. So when I do that, I'm going to get 6x squared, that's 6, that's not negative 6, and then I'll get negative 4x, and now 5 will go meet the neighbors, and I get 15x and negative 10, and then when I add these all up, I get 6x squared, 11x, and negative 10. And naming it, it's just like the one before. The highest power is squared, so that's quadratic. Trinomial. Okay? All right, E. So E is a little tricky because that squared actually means there were two of these. This is technically another neighbors meets neighbor situation. And these are the same. Remember, this is what we would call a perfect square, trinomial, when we're done. So first x is going to go visit, and I get x squared and 6x, and then the 6 is going to go visit, and I get another 6x with 36. So when you're done adding them, this is your answer. And again, same type as we've had a lot of. This is a quadratic trinomial. All right, 5. This is what we call, once it's factored, a difference of squares. But this is neighbors meet neighbors, so I'm going to have x visit first. Let me add the opposite here. I'm going to get x squared and negative 10x. And then the 10 will go visit. And I'll get negative 100. And when I add these, I actually have a set that cancels out. So I'm not going to write 0x. I'm just going to write x squared plus negative 100. So this is a quadratic, but now I only have two terms. So that I will call a binomial. All right, G, another neighbors meets neighbors problem. So first, just adding the opposite. And I'll have x go visit everyone first. So that's going to give me 2x cubed. If you want some numbers here, you could put some 1s. And then that would give me, when 1x meets 1x, that would give me 1x squared. Remember, we're multiplying, not adding. And 1x meets negative 3, and that's negative 3x. And now the negative 3 can go visit everyone. And I get negative 6, negative 6x squared. Negative 3 with 1x gives me negative 3x. And negative 3 with negative 3 gives me a positive 9. And I can add them up. This gives me negative 5. Here's a negative 6. Nothing cancels out here. And whoops, that's supposed to be 3, not a 2. So this is a cubic due to that third power. And this is the first time we've had more than 3 terms. So when it's just more than 3, we call it polynomial. All right, H. There's one definitely like this on the test, and we had this on the quiz. So when we talked about this on the quiz, first we talked about that, here's some neighbors that meets neighbors, and that this is actually an x plus 2. 2 of them, and whoops, sorry, you can't see that, and those are going to meet. So I'm going to start with the first set of neighbors, have those meet, and then go to the other set of neighbors, have those meet, and then show you what we do from there. So just adding the opposite here, this first set. First x is going to go visit, and I'm going to get x squared plus 3x. Then the negative 2 will visit, and I get negative 2x and negative 6. So when I'm done with this set, I get x squared plus 1x plus negative 6. Now I'm going to go to this stuff, and that there were 2 x plus 2's, and I'll have these neighbors meet. So I'm going to get x squared and 2x, and then the 2 will meet, and I'll get another 2x and 4. And then, hold on one second. All right. And then we're going to add these up. And so now what's supposed to happen is all of this, which I'm going to wrap it in parentheses, this is supposed to subtract all of this stuff. So now what I'm going to do is go through and act like this problem that I have here on the bottom row is just like, B or C, or I'm sorry, A or B. So I'm going to go left to right, and I'm going to add. And I'm going to do the opposite of each one. And, whoops, and then I can rewrite it. So x squared and 1x and negative 6 will join a negative x squared, a negative 4x, and a negative 4. And again, if you want to put numbers there, you can. But what will end up happening is these will cancel out. I'll get a negative 3x, and when I add these, I get a negative 10. So when I name this one, there's an understood first power, so it's linear. And since there's 2 terms, binomial. And that was definitely a tougher problem, which we had on our first quiz. Very similar. All right. Number 3. So the idea of number 3 and 4 is we are going to create our own questions. So we're going to give an example of 2 quadratic trinomials that add to a linear monomial. So I'm going to give you one example, and then I want you to try another one. So two quadratic trinomials. So quadratic means our highest power is a 2, and then I need 3 terms in total. So let's say I start with 3x squared plus 4x plus 7, okay? So I'm going to come up with another quadratic trinomial right below it so that when I add them up, I'll have a linear monomial. So a linear monomial means that my highest power is a first. So what will actually have to happen is I'll have just a linear monomial. So it's something that looks like this. This is a linear monomial. So when I add these up, these will have to cancel out and these will have to cancel out. So the only thing that can make 3x squared cancel out is negative 3x squared, and the only thing that they cancel out for 7 is negative 7. And then I can just pick anything with an x. I could just pick 1x, for instance, and when I add these up, I get a linear monomial. So there's the linear with the first power, and monomial, there's only one term. So you don't have to make yours look that different from mine, but I want you to try that. So pause. And then number 4. So give an example of 2 linear binomials. So again, linear means that the highest power is going to be a 1 and that I have 2 terms. And I'm going to multiply them so I get a quadratic trinomial. So I'll make up 1. So I'll do 2x plus 1. So it's linear because again there's a first power. It's binomial because it's 2 terms. So I'm just going to come up with another one, x plus 3. And when I multiply these, I should end up with a quadratic trinomial. So just showing how that works. 2x squared, 6x, then 1's going to go visit, and I get a 1x, and 1's going to visit 3, and remember, we're multiplying, that's 3, and when I add these up, here comes my quadratic, there's the quadratic trinomial, 3 terms. So you just try one over here. All right, 5, definitely one like this on the test. The idea is I want this neighbor to meet this neighbor so I can get it in standard form. I'm going to go from factored form to standard form, and then I'll be able to say what A, B, and C are. So first, 2x is going to go visit. So I get 6x squared, and then I get 4x, and then the negative 1 is going to visit. So I'm going to get a negative 3x and a negative 2. So when I add these up, I get 6x squared plus 1x plus negative 2. So what's A, what's B, and what's C? Well, A is the one next to x squared, so A is the 6. It's not 6x squared, it's just 6. X squared told me that A was next to it. B is next to x, so B is going to be a 1. And C, remember, this is plus, so you got to make sure this is plus. C is the negative 2. So we've identified what A, B, and C are. All right, now we're going to get into some stuff that's the completing the square. So remember, completing the square is just, you know, we take a number, we cut in half, we square it, we add a blank, subtract a blank, but this is just part of it. So what I'm going to do here, and I'm going to kind of do some different ones first. I'm going to start with B, is what I want to know is, so let's read the directions. Find the missing term to complete each perfect square trinomial. Then you're going to write it into factored form and vertex form. So what I want to know is if I take this number and cut it in half and get 6 and then square it, that 36 should go in the blank. So this is standard form, and now what I'm going to do is factor it to get it into factored form. So I'll do that over here. I apologize, there's not a lot of room. But the idea is when I do this, what are factors of 36? X squared, they get me to 12x. Remember, this is the long way. And then I could rewrite it into x squared plus 6x plus 6x plus 36. So when I group these now, the GCF I'll take out of this is x. So x and x make x squared. X plus 6 give me that. And I'm going to go for my matching set. So what with x gives me 6x, or what with 6 gives me 36. That's a 6. And now I can write it as factored form. X plus 6 and x plus 6. Now, vertex form, if you guys remember, is just going back to this, is something squared. And if you have it in factored form, if you actually just write it like this, this is your vertex form. So this one's already done. So factored form, vertex form, standard form.